Today's video is all about interpreting linear equations. After this lesson, you want to be able to identify the dependent and independent variables in a relationship and interpret the slope and y-intercept of an equation. Let's first start with some independent and dependent variables. The independent variable represents the input, the x value of a function. The dependent variable represents the output, the y value of a function. The value of the dependent variable depends on or is a function of the value of the independent variable. So let's look at an example. Suppose I want you to identify the independent and the dependent variables. We're talking about a relationship between the cost of shipping a package and its weight. I first want to think to myself, which one depends on the other? The cost of the shipping depends on the weight. That means that the dependent variable is the cost because it depends on something else. The independent variable is the weight, which means if we were to graph these or write an equation, x would be our weight and y would be our cost. Our independent variable always goes on our x-axis. Our dependent variable always goes on our y-axis. Let's look at another one. For every minute that the faucet is on, the water level in the bathtub rises 2 inches. So we have two variables here. We have minutes that the faucet is on, and we have the water level in the bathtub. So we're looking at the relationship between minutes and the water level in the bathtub. We want to think about which one depends on the other. The water level depends on the number of minutes that the faucet has been on, which means the dependent variable is the water level because it depends on something else. If we think of that backwards, if I were to run the water level higher, it's not going to change the amount of time that has passed. That's impossible. Often time is independent because we can't change the amount of time that something has been going on. Interpreting slope and y-intercept. In an equation written in slope-intercept form, which is y equals mx plus b, m is the slope and b is the y-intercept. The y-intercept is just the y value when x equals 0. The slope is just the change in the y variable for each 1 unit of increase in the x variable. Let's look at an example here. We've got the equation below that shows the cost of a hamburger with different numbers of toppings. So we've got cost is equal to $1.40 times t plus $1.90. Let's first look at our independent variable and our dependent variable before we start. Even though we don't have an x and a y, that doesn't mean we don't have an independent variable and a dependent variable. We're looking at the relationship between the cost of the hamburger and the number of toppings. Well, the cost is going to depend on the number of toppings. That means that our independent variable is toppings and our dependent variable is cost, again, because cost depends on the number of toppings. Let's make sure we're able to look at our equation and identify our y-intercept. Our y-intercept is a constant that does not have a variable in a linear equation. In this case, that number is $1.90. Now, in order to interpret the y-intercept, that means explain what it means in words, using words from the problem and using the number itself. An interpretation of the y-intercept here would be when the number of toppings t is 0, then the cost is $1.90. So the y-intercept, remember, is what happens when x is 0. Our x value, our independent variable, was toppings. So when our number of toppings t is 0, then the other variable, in this case the cost, is $1.90. Let's take a look at our slope. In this case, our slope is $1.40. Our slope is the number that is next to the independent variable in this case. In this case, it's our number of toppings. Interpret the slope means we're going to explain what it means in words. In this case, it is for every 1 increase in toppings, for every 1 increase in our independent variable, the cost increases by $1.40. The cost increases by the slope. If you need one, you can memorize a script to interpret the slope and the y-intercept. So, in order to interpret the y-intercept, you can always use this fill in the blank. When whatever the x variable is 0, then whatever the y variable is now your y-intercept. To interpret the slope, for every 1 increase in the independent variable, then the dependent variable increases by whatever the slope is. So let's look at an example to see if we can understand a little more clearly about what to do with these fill in the blanks here. We've got Charlie renting a moving truck. He paid a daily fee plus a per mile fee to rent the truck. The equation below represents the daily amount Charlie paid for the truck if he drives it X miles. So we're looking at the relationship between the daily amount Charlie paid for the truck and the number of miles. The amount that he is going to pay depends on the number of miles, which means our independent variable is miles, which is our X variable, and our dependent variable is the daily amount, which is our Y value. See if you can identify the y-intercept and the slope now. Remember, the y-intercept is the constant that doesn't have a variable. So in this case, it's 10. If I were to write that as a point, don't forget it would be 0, 10. The slope is the number that's with the x, so that's 0.5. So let's see if we can interpret this by filling in the blanks. To interpret the y-intercept, in this blank always goes whatever our independent variable is. So when the number of miles driven, when miles driven is 0, because that's our independent variable, then whatever our dependent variable here goes in the next blank. Then the daily amount is, and then the number in here is just the y-intercept, and I should always put units on there. So what that means is if I were to go in and rent the truck, I drive it 0 miles, I'm still going to have to pay $10 per day. That's my interpretation for the y-intercept. Now, to interpret the slope, for every one increase in whatever your x value is, whatever your independent variable is, for every one increase in miles driven, the dependent variable, the daily amount, maybe we should say daily amount paid here, just to make that flow a little more nicely. The daily amount increases by 0.5. Let's make sure that makes sense to us. Remember that this is X miles, and Y is our daily amount paid. So our daily amount paid increases by, we don't want to say 0.5, we want to treat that as 50 cents. So I'm going to write that as 50 cents, not $50, 50 cents there. So at this point, you should now be able to identify your dependent and independent variables in a relationship and interpret the slope and the y-intercept of an equation.